Hello friends, this is a demonstration video of the art gallery problem and along with its modifications. So here this is the snippet of the code file. So here this is the readme.txt. So here initially we have described the problem statement along. Now further this is the features part. Here we have described all the features that are included in the code. uh, so let's start with the features. So first we have the random polygon generation feature. So here we are generating the random polygon uh, via the input number of nodes that are being given. Then we are doing the vertical trapezoidization by decomposing the polygons into the trapezoids. Then third we have the monotone partitioning of the polygon where the merges trapezoid into monotone pieces. Then we are doing the triangulation or the air clipping of the polygon. Then we are showing the dual graph construction of the polygon. Then we are doing the three color scheming of the polygon. After which we are also defining the minimum number of guards needed by using the three coloring scheme. Then for the part of the modification in the art gallery problem, what we have decided to do is to add a drone feature in the problem where instead of the guards at the vertex guards, we have assigned a drone in some triangulation in the triangular parts of the polygon, so that when we can decide the most optimal number of drones, so that we can cover the whole polygon at a given number of time using the drones. The drones have a set period of fuel length and the distance, along with all the mm, updatable features in it. So in this third last features, we are describing the drone path planning and its animation. Then finally, we have also made a fully interactive GUI to so that the user can easily integrate or interact with all the features that are being implemented into the problem. Here we have the project structure of the code. So basically, the main file here is the main.py which we have to run, which combines all the components and modular parts of the code. We have also defined the installation requirements and output, the various output file that will be generated, the GUI controls, and the basic the structure of the code that it's following. So let's start by running the code. So this is the main.py file. Here we have to run the code via running the command /run. Then we will have to give the input number of nodes. So let's start with initially 15 nodes. So this is the GUI interaction window. So here we can see that a 15 node polygon has been generated on a random basis. So in the bottom, we can see the various features that were implemented as discussed before. So let's start with each one of them. Initial one is the polygon. Another one is the trapezization of the polygon. Then we are doing the monotone part, seeing the monotone parts of the polygon by connecting the diagonals of the trapezoids. Further, this is the triangulation of the polygon. Um, we can also construct the dual graph from this triangulation, as we can see in the next feature. So this is a dual graph generation over the triangulation of the polygon. Now we have implemented a three coloring scheme where basically we are using this three coloring scheme to decide the minimum number of vertex guards that are needed. So we can see that the minimum number of vertex guard needed are three based on the three coloring scheme, as green is the minimum number of colored used on the vertices. Then for the modification part in the art gallery problem, there as we have added the drone part, in the last feature, we can see the path of the drones and the optimal number of minimum drones required to cover the whole polygon at a given time. So using this animation play button, we can see the animation of the drones such that at a given number of time, all the drones together are covering the whole polygon so that there are no blind spots left. Here we can also adjust the speed of the animation by delaying it or increasing it. So now moving forward with the next example, let's rerun the file. Now use a 20 node polygon generation. Here we can also see that the output files that are being generated are rewritten upon the rerunning of the code every time, so as to have the optimal storage use. So we can see again a polygon of 20 nodes has been generated. And now seeing all the features again, the trapezization of the polygon, the monotone part of seeing the monotone of the polygons, the triangulation of the polygon, the dual graph visualization of the polygon, the three coloring scheme implementation, and deciding the minimum guards needed based on the three minimum coloring scheme implementation. Now for the drone modification, we can see the parts of the drone, minimum optimal drones needed to cover the polygon at a given time. Now playing the animation. Now let's move forward with the next example. This time let's use 40 node polygon generation. So this is the 40 node polygon generation. The polygon has been generated. The trapezoidization of the polygon, the monotone polygon, the triangulation of the polygon, the dual graph visualization of the polygon, recoloring scheme implementation, and deciding minimum guards based on it. Now for the drone modification, this is the minimum optimal drone routes required to cover a polygon at a given time, and the drone implementation animation. Now moving forward with the another example, let's generate a polygon of 60 nodes. So a random polygon of 60 node has been generated. So the polygon, the trapezoidalization of the polygon, the monotone polygon, triangulation of the polygon, dual graph visualization, recoloring scheme of the polygon, and minimum guards decided on three coloring scheme. Now finally, the drone route visualization via the animation. Now moving onward to the final example. Now let's use 30 node polygon generation. So this is the 100 root polygon generation. Okay. So this is the 100 root polygon generation. The polygon, the trapezoidalization of the polygon, the monotone polygon, the triangulation of the polygon, the dual graph visualization of the polygon, recoloring scheme, and minimum guards. Now visualizing the drone route animations. So here, as you can see explained, at a given time, all drones are covering the whole polygon. So thank you. That was it for the explanation of the group project.